Hey everyone, welcome to this one-shot smart revision explainer. If you've ever felt completely overwhelmed by all the shapes, the rules, and the endless angles in Chapter 3, Understanding Quadrilaterals, absolutely don't worry. We're going to dive right in, demystify all these concepts, and lock this geometry logic into your memory once and for all. So let's get started.
Here's our quick roadmap for today. We'll start with the basics of polygons, move into angle-sum properties, break down the types of quadrilaterals, dive into the properties of parallelograms, and finally, wrap up with special parallelograms.
But before we get bogged down in definitions, I've got a quick challenge for you. Take a look at the question on the screen. Could you find the unknown angle x in just 10 seconds? If you're hesitating even a little bit, stick with me. By the end of this explainer, you will absolutely be able to solve an unknown angle problem exactly like this without breaking a sweat.
All right, let's kick things off with Section 1, the basics of polygons. This is the absolute foundation.
So what actually is a polygon? Well, it's simply a simple closed curve made up entirely of line segments. And the specific words here are absolutely crucial. It must be closed, meaning the starting and ending points are exactly the same, absolutely no gaps. It also has to be simple, meaning the lines never cross or intersect each other. And finally, it has to be made purely of straight line segments. If a shape checks all those boxes, you got yourself a polygon.
Now, it's pretty interesting how we can break polygons down into two main categories, just based on their interior angles. On one side, we have the concave polygon. The easiest way to remember this? Think of it as literally caving in. For a polygon to be concave, at least one of its interior angles has to be strictly greater than 180 degrees. On the flip side, we have the convex polygon, where every single interior angle is strictly less than 180 degrees. They all just point outwards. Getting this clear, side-by-side comparison locked into your memory is super important.
We can also categorize them by their sides and angles. A regular polygon is basically the absolute perfectionist of shapes. Every single one of its sides is equal in length, and all of its interior angles are perfectly equal in measurement. A square or an equilateral triangle. Perfect examples of regular polygons. But then you have irregular polygons, where things get a bit messy. The sides and angles vary in their measurements. Think of a standard rectangle or a rhombus. Either the sides aren't all perfectly equal, or the angles aren't.
Moving right along to Section 2, Angle-Sum Properties. These are the golden rules of the game.
If there is one massive, completely unforgettable rule you take away from our whole session today, let it be this exact number, 360 degrees. The sum of the exterior angles of any convex polygon, and I mean any, no matter if it has 4 sides, 15 sides, or 24 sides, is always exactly 360 degrees. Crazy, right? So, how do we actually put that 360-degree rule to work? Here are the straightforward, logical steps. Step 1. Identify the given exterior angles provided in your problem. Step 2. Add all those known angles together. Step 3. Simply subtract that total sum from 360 and boom! You've just found your unknown exterior angle x. Kya aapko samajh aaya? It's a ridiculously simple 3-step formula that works for you every single time.
All right, Section 3, Types of Quadrilaterals. Let's meet the main cast of shapes.
First up in our quadrilateral family, we have the trapezium and the kite. These two have very, very specific traits. The trapezium features exactly one pair of parallel sides. That's the whole requirement. Just one pair of opposite sides running in the exact same direction that will literally never meet. Now, the kite is a completely different story. It features exactly 2 distinct consecutive pairs of sides of equal length. That means the sides right next to each other, the ones actually touching, are equal, rather than the opposite sides. Keep an eye out for these unique markers.
Which brings us to Section 4, Properties of Parallelograms. This is the VIP parent shape.
Pay extremely close attention here, because these right here are the absolute golden rules of parallelograms. First, both pairs of opposite sides are perfectly parallel. Second, those same opposite sides are completely equal in length. Third, the opposite angles have the exact same measurement. Fourth, the diagonals bisect each other, meaning they cut each other perfectly in half right at the center. And finally, adjacent angles, so the angles right next to each other, are supplementary, meaning they add up to exactly 180 degrees. Truly grasping these 5 rules is your ultimate key to mastering this entire family of shapes.
And let's see how we practically apply those parallelogram properties to crush standard exam questions. Imagine you have unknowns x, y, and z to solve for. Step 1. Use your adjacent angles. If you know one, just subtract it from 180 degrees to find the angle next to it, like x. Step 2.
Use your opposite angles. They are completely equal, so finding y is often just literally copying the angle straight across from it. Step 3. Dig up your parallel line rules from past geometry lessons. Look for those alternate interior angles forming a Z-shape right across the diagonal. That is an awesome shortcut to find Z.
All right, the final stretch, Section 5, Special Parallelograms. Time to meet the elite offspring. Meet the first elite kid in a family, the rhombus. A rhombus takes everything a basic parallelogram is and gives it a massive upgrade. Instead of just having opposite sides equal, in a rhombus, all 4 sides are perfectly equal in length. Basically, think of it like a parallelogram that's just been squared up on its edges. But here's the absolute game changer. While the rhombus inherits all those standard parallelogram properties, it has its own secret superpower. Its diagonals don't just bisect each other, they bisect each other at exactly 90-degree right angles. When those diagonals cross in the very center, they form 4 perfect 90-degree angles. It's an incredibly test-heavy superpower, for sure.
Next up is the rectangle. A rectangle is a special parallelogram where every single interior angle stands perfectly straight up at exactly a 90-degree right angle.
And because the rectangle stands up so perfectly straight with those 90-degree corners, it unlocks a totally different superpower. Its diagonals are stretched to be exactly equal in length. They still bisect each other, because hey, it's still a parallelogram, but now the total length stretching from corner to corner is perfectly matched.
And finally, we reach the square. The square is literally the ultimate shape. It's a regular polygon that basically inherits all the powers from the entire family tree. It has all 4 equal sides like a rhombus, and all 4 90-degree angles like a rectangle, which means its diagonals are perfectly equal, they bisect each other, and they intersect at perfect 90-degree right angles. It's got the whole shebang.
Now this summary right here, treat it as your ultimate cheat sheet. Notice how the parallelogram acts as the base parent shape. The rhombus upgrades the sides and the diagonal angles. The rectangle upgrades the interior angles and the diagonal lengths. And the square, it just boldly checks every single box. If you can grasp this interlocking logic, you are seriously going to be unstoppable on your exam. And that actually brings us to the end of our explainer today. But before you go, I want to leave you with a bit of a challenge. Look around at a shape in your room right now. Maybe it's a window, a computer screen, maybe a floor tile. Can you classify exactly what type of quadrilateral it is? And can you instantly state all of its hidden properties purely from memory? Apply this taxonomy to the real world, and I promise you'll never look at shapes the exact same way again. Thanks so much for exploring this with me today.